Hi there and welcome to yet another video in this series of stoichiometry. We've been dealing with different topics under the concept of stoichiometry, seeing how they work, solving questions, giving examples and exercises. In this video, we want to talk about the mole formula. The mole formula. It's been an interesting series thus far, and if you're stumbling on this video for the first time, my name is David and I'm an online chemistry tutor for high school kids. I want you to sit back, relax, and enjoy every bit of what I've got for you in this video. So without wasting time, let's get into what we have. The mole formula is an interesting formula in chemistry, and especially the topic of stoichiometry. It has a whole lot of things that it helps us to do. That formula is written as N is equal to M divided by M. I'll explain what they mean. N is equal to small letter m divided by the big letter M. Each of these letters have what they represent. N stands for the number of moles. M, the small one, stands for the mass of the substance in grams, while the big letter M stands for the molar mass or the molecular mass. In our previous video, thankfully, we saw how to calculate the molar mass of a substance. N stands for the number of moles. So if you're given a question where you're asked to calculate the number of moles and you have the mass of the substance, you also have the molar mass of that substance, you can calculate it using this formula. So let's see if we can take some examples. Now, to do this, there are a number of steps that you need to take. Okay, so step number one would be to write the formula. Step number two would be to identify what is given. Step number three would be to calculate or find the molar mass if needed. Step number four would be to substitute and solve. So let's see if we can take some examples. Example number one deals with the mass to mole concept. So let's take the example. We have the example that says calculate the number of moles in 18 grams of water. Calculate the number of moles in 18 grams of water. Step number one, write the formula. What is the formula of water? The formula of water is H₂O. So step number one, H₂O. We've written the formula. What does step number two say? Step number two says identify what is given. We are asked to calculate the number of moles in 18 grams of water. 18 grams of water. Identify what is given. Step number two. We have 18 grams of water. So let's see what step number three says. We have 18 grams of water. Step number three will be to calculate or find the molar mass if needed. Calculate or find the molar mass. We can calculate the molar mass of water, H₂O. How do we do that? We simply substitute the individual atomic masses. Now, hydrogen has the atomic mass of 1 and oxygen has the atomic mass of 16. So if we're to calculate the molecular mass, it becomes hydrogen appears just 2 times and oxygen appears once. So this becomes 2 multiplied by 1, which is the atomic mass of hydrogen, and oxygen becomes 1 times 16. So we have 2 and we have 16. Altogether, it becomes 2 plus 16. This becomes 18 grams per mole. This is the molar mass of water. We have 18 grams per mole of water. That's the molecular mass. So step number 4 says to substitute and solve. So how do we substitute and solve? The formula or the mole formula says N, number of moles, is equal to M, the mass of the substance, divided by M, the molar mass of the substance. So N, which is the number of moles, is not known. It's not given. It's equal to the mass of the substance. What is the mass of the substance? 18 grams of water. We have 18 divided by the molar mass of water, which we calculated to be 18 as well. So we have 18 divided by 18, which is 1 mole. So the number of moles is simply 1 mole. So if we go back to the question, calculate the number of moles in 18 grams of water, it is simply 1 mole. Easy peasy and straight to the point. I trust you're getting massive value for what's been put out in this video. If you are, please go ahead and consider subscribing to this YouTube channel, like this video, and share to as many as you can. Let's move on to see if we can do another example. We have example number 2 on the screen that says, calculate the number of moles in 44 grams of carbon dioxide. Step number 1, write the formula. What's the formula? CO2. Step number 2, identify what's given. What is given? We have the mass of carbon dioxide, which is 44 grams. Step number 3 would be to calculate the molecular mass of carbon dioxide. How do we do that? Well, we have CO2. Carbon appears just once, oxygen appears 2 times, and carbon has the atomic mass of 12, oxygen has the atomic mass of 16. So this becomes 1 times 12 for carbon. This is equal to 12. And then we have 2 times 16 for oxygen. This is equal to 32. Altogether, we have 32 plus 12. This gives us 44. So we have 44 grams per mole as the molecular mass for carbon dioxide. Step number 4 would be to substitute and solve. The formula says N, the number of moles, is equal to the mass of the substance, M, divided by the molecular mass of the substance, capital M. So N is equal to, what's the mass of the substance? 44 grams divided by the molecular mass, which is also 44. We still have 1 mole as the answer. So can you see how these 4 steps were brought into synergy to attain the answer to the question? Thirdly, we have a question on the screen that says, calculate the number of moles in 88 grams of CO2. Well, step number 1, the formula, we have CO2. Step number 2, identify what's given. We have 88 grams of CO2. Step number 3, calculate the molar mass. We've already calculated the molar mass of CO2 in the previous question to be 44 grams per mole. And then step number 4 would be to substitute. So step number 4, we have the number of moles, N, is equal to the mass of the substance divided by the molar mass, M. The mass of the substance is 88 grams this time, divided by the molar mass, which is 44. We have 2 moles as our answer. So let's put that down, 2 moles. So can you see how all these things are coming into play to answer the question of finding the number of moles? Now we're coming to the point where we are rearranging the formula. So let's see if we can learn a thing or two about this. Now the question says find the mass, not the number of moles. Find the mass. Well, step number 1, let's take it gradually. Write the formula. We have water, which is H₂O. Step number 3, or step number 2 rather, we have identify what is given. We have 2 moles of water. That's the data we were given. Step number 3 would be to calculate the molar mass. What's the molar mass of water? Well, we have H₂O. Hydrogen appears once. Hydrogen appears twice, I beg your pardon. Oxygen appears once. So we have hydrogen, which becomes 2 times. The atomic mass of hydrogen is 1 and the atomic mass of oxygen is 16. So we have 2 times 1, which gives us 2. And for oxygen, we have 1 times 16, which gives us 16. Altogether, we have 16 plus 2, which gives us 18. So the molecular mass of water is 18 grams per mole. Step number 4 would be to substitute and solve. Remember, the formula says N, number of moles, is equal to the mass of the substance divided by the molecular mass. Now we have the value for N, which is 2 moles of water. We don't have the value for m. M is not known, but we have the molar mass, which is 18. So let's substitute. 2 is equal to m divided by 18. At this point, we can cross multiply. So m is equal to 2 times 18. This is 36 grams because m is the mass of a substance. It is measured in grams. So we have 36 grams of water, H2O, as the answer. I'm sure you saw how we solved this. We rearranged the formula to suit finding the mass. Let's check out another example. The example on the screen says find the mass of 3 moles of oxygen gas. Well, step number 1, write the formula. The formula is O2, oxygen gas. Step number 2, identify what's given. We have 3 moles as the data given to us. Step number 3, calculate or identify the molar mass. Well, we have oxygen O2. What's the molar mass of this? Well, it's simple. Oxygen appears 2 times. So we have 2 multiplied by the atomic mass of oxygen, which is 16. So 2 times 16 gives us 32 grams per mole. So let's put that out. 32 grams per mole. And then finally substitute and solve. Step number 4. The formula says N, number of moles, is equal to the mass of a substance divided by the molecular mass. N is given as 3, the mass is not known, and the molecular mass was calculated to be 32. So we have 3 is equal to m over 32. So m is equal to 3 times 32. 3 times 32, let's do that very quickly. This is 6 and this is 96 grams as the mass. 96 grams of oxygen, O2. So you can see how this was done. Mass is measured in grams. We have another example on the screen that says a sample has a mass of 36 grams and contains 2 moles. Calculate the molar mass. A sample has a mass of 36 grams and contains 2 moles. Calculate the molar mass. Well, step number 1, write the formula. There is no formula here, so there's no need to do that. Step number 2, identify what's given. We have 36 grams as the mass, and we also have number of moles to be 2 moles. Step number 3, calculate the molar mass. Well, that's not needed because we already have the molar mass to be. Okay, we don't have the molar mass, I beg your pardon. Calculate the molar mass. That's what we're asked to do. So how do we calculate the molar mass? Let's write out the formula. We have N is equal to m divided by m. Now we know N stands for the number of moles, which is 2. The mass m is 36 and this guy is not known. So let's put in our values. This becomes 2 is equal to 36 divided by m. If we cross multiply, this becomes 2m is equal to 36. So we divide both sides by 2 to get the value of m. 2 cancels 2 and we have m is equal to 18. The molar mass is 18 grams per mole. So step number 4, final answer is 18 grams per mole. That's for the molar mass. I'm sure you've seen how all of these things are coming into play. Then we have this question on the screen that says calculate the number of moles in 64 grams of oxygen gas. The number of moles in 64 grams of oxygen gas. Step number 1, write the formula. The formula for oxygen gas is O2. Step number 2, identify what's given. What is given to us is 64 grams as the mass for oxygen gas. Step number 3 would be to calculate the molar mass. The molar mass for oxygen gas, as we calculated in the previous question, is 32 grams per mole. Now, if you don't know how I got 32, I simply multiplied these 2, which is the subscript here, times the atomic mass of oxygen, which is 16. That gives us 32 grams per mole. Okay, so we have 32 grams per mole. And then finally substitute the values. So the formula says N is equal to m divided by the molar mass. The number of moles, we don't know what it is, it's unknown. The mass is 64 and the molar mass is 32. So we have N is equal to 64 divided by 32. That gives us 2 moles. So the answer to this becomes 2 moles. So you can see how all these values can be calculated using the mole formula. Pretty easy, pretty straight to the point. So the summary of all we've been saying since the commencement of this video is the mole formula is simply N is equal to M divided by M. To find moles, divide mass by the molar mass. So the number of moles N is equal to the mass divided by the molar mass. That's what the second point is saying. To find mass M, you simply multiply moles by the molar mass. So to find M, M will be equal to the number of moles times the molar mass M. And then third point is saying to find molar mass, capital letter M, we divide the mass by the moles. This becomes small letter m divided by N. And then fourthly, always calculate the molecular mass first when necessary and include units in your answer. Follow the 4-step solving method like you saw me do. So now that we understand all of this, it's time for some practice questions. Calculate the number of moles in 18 grams of water, 44 grams of carbon dioxide, CO2, 32 grams of oxygen, and 28 grams of nitrogen gas. We have the atomic masses for each element present. Number 2, calculate the number of moles in 98 grams of sulfuric acid, H₂SO₄, 58.5 grams of sodium chloride, 40 grams of magnesium oxide. The atomic masses that you need are also listed below. Thirdly, find the mass of 2 moles of water, 3 moles of CO2, 0.5 moles of water. All the values that you need are also given below. And then fourthly, you have find the mass of 4 moles of sodium chloride, 2.5 moles of magnesium oxide, 0.25 moles of H₂SO₄, sulfuric acid. And then fifthly, a substance has 54 grams and number of moles is 3. Calculate the molar mass. You saw me do an example that was similar to that, so this shouldn't be a hassle for you. Secondly, or sixthly, a sample has 88 grams. The number of moles is 2. Calculate the molar mass. And then seventh, we have calculate the number of moles in 72 grams of water. Okay, the formula of water is H2. The values of H is 1 and oxygen is 16. And then the 8th question says find the mass of 1.5 moles of carbon dioxide. Pretty plenty number of questions to keep you busy. And then lastly, we have this question that says a compound has a mass of 120 grams and contains 3 moles. Calculate its molar mass. Calculate its molar mass. Just go ahead, take your time, solve these, and drop your answers in the comments where I'd be waiting to see them. And up until the next segment of this series where we deal with stoichiometry with chemical equations, I can't wait to see you there. It's been an awesome time thus far, and I trust you got massive value for what was put out in this video. Up until the next one, my name remains David and I'm an online chemistry tutor for high school kids. Enjoy the rest of your time and I'll see you in the next video. Up until then, stay blessed.